Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. By now, you should know the formula for the product and quotient rule. If you have no idea what I'm talking about, go watch the previous intro video first. Today, we're taking the training wheels off and diving deeper into those two formulas. But before we do that, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. So the product rule says that if we have f times g and we want to find the derivative, that is going to be equal to f prime times g plus f times g prime. So this is our product rule. Our quotient rule says that if we have f divided by g and we want to find the derivative, that is going to be equal to f prime g minus f g prime, and then we're going to have that over g squared. Now the first example, we want to find f prime of x, and here we can see that we have a quotient. So our numerator here is x times e to the x, and then our denominator here is x squared plus 1. So some of you may already notice that we need both the quotient and the product rule. We need the quotient rule because here we have a fraction, but we need our product rule because our numerator here is x times e to the x. But don't worry, that's not going to be a problem. We just need to do this step by step. So first, because this is in a fraction, we're going to be applying our quotient rule, which means we have f prime of x is equal to the derivative of the numerator, so that'll be d by dx of x times e to the x, multiplied by our denominator, which is just x squared plus 1. And then we're going to subtract our numerator, multiplied by the derivative of our denominator, which is x squared plus 1. And then we're going to take that, and this is going to be over the denominator squared. So that's x squared plus 1 squared. So now, notice how we need to apply the product rule to this one over here. So if you want, you can actually do that on the side. So d by dx of x times e to the x, that is going to be equal to, using our product rule, we're going to have the derivative of x, which is 1, times e to the x. And then we're going to add x times the derivative of e to the x, which is still e to the x. So now we can take this and substitute it back in. That means this is equal to e to the x plus x times e to the x multiplied by x squared plus 1. And then we're going to be subtracting x times e to the x, and then the derivative of x squared plus 1 is just 2x. And then we still have our denominator, which is x squared plus 1 all squared. So now notice that we can pull out an e to the x from here and then an e to the x from here. So let's go ahead and factor that out. So we get this is equal to e to the x times 1 plus x times x squared plus 1 minus x times 2x. So that is 2x squared. And then we have this over the denominator, which is x squared plus 1 all squared. And then the last part, we can go ahead and expand out 1 plus x times x squared plus 1. So we end up with e to the x times x cubed plus x squared, but then we need to minus the 2x squared. So we end up with minus x squared. And then we have plus x plus 1. And again, we have this over our denominator, which is x squared plus 1 all squared. And we're not going to bother with expanding out the denominator. So this would be our answer. So notice how if you have nested products and quotients, there's no need to worry. You just need to follow the formula and go through it step by step and arrive at your solution. Next, we're going to take a look at a problem where the function is not actually given. Instead, we're only given a table of values. Note that this is actually a very common AP IB problem, and they're using this to check if students understand the structure of the rule, not just moving variables around. And here we want to find h prime of 3, where h is f divided by g. So in order to find h prime of 3, we need to first figure out what the derivative of h is. And we're going to be using the quotient rule for that. So h prime of x is going to be equal to f prime of x times g of x minus f of x times g prime of x, and then this is over g of x all squared. And now, in order to find h prime of 3, we just need to substitute in x is equal to 3. So this means h prime of 3 is equal to f prime of 3 times g of 3 minus f of 3 times g prime of 3, and then this is over g of 3 all squared. And to find the values of that, we just need to look at our table. So the table here says that when x is equal to 3, these are the values for f, f prime, g, and g prime. So that tells us f prime of 3 is equal to -2, and g of 3 is equal to 2, and f of 3 is equal to 4, and g prime of 3 is equal to 5. And this g of 3 here is also equal to 2. So now we have this is equal to -2 times +2 minus 4 times 5 over 2 squared. And this evaluates to -6. And now for our last example, we want to prove that the product rule is true by using the formal definition of a derivative. So in other words, we want to prove that f of x times g of x, when we take the derivative, it is going to be equal to f prime of x times g of x plus f of x times g prime of x. So this equation in red here is what we want to prove. Now let's say we're going to let a of x be equal to f of x times g of x. Then using the formal definition of a derivative, this tells us that a prime of x is equal to the limit as h approaches 0 of a of x plus h minus a of x over h. And since a here is f of x times g of x, we can go ahead and substitute that in. So then this is equal to the limit as h approaches 0 of a of x plus h would be f of x plus h times g of x plus h. And then we have minus f of x times g of x. And this is over h. Next, we're going to do a little trick. So we're going to add and subtract f of x plus h times g of x in the numerator. So by adding and subtracting the same term, we've essentially added 0. And we can always do that, because adding 0 doesn't affect the equation. So we get this is equal to the limit as h approaches 0 of f of x plus h times g of x plus h. And then just in a different color so that you can see, I am going to add f of x plus h times g of x. And then I'm going to subtract the exact same thing. So f of x plus h times g of x. And then we have the minus f of x times g of x. And this is still over h. And now what we're going to do is we're actually going to group this term with this term. And then we're going to group this term with this term. So by grouping, I mean that we can actually factor out an f of x plus h from both of these terms. And then we can factor out a g of x from both of these pink terms. So if we did that, we're going to get this is equal to the limit as h approaches 0 of So factoring out the f of x plus h, we're going to be left with g of x plus h minus g of x over h. And then combining the two terms highlighted in pink, and then factoring out a g of x, we're going to get f of x plus h minus f of x over h. Okay, and remember we're taking the limit as h goes to 0 of this entire thing. And now we're ready to apply our limit law. So recall that we can apply this limit law to each of those terms individually. So we can apply our limit to these four terms separately, which means this is going to be equal to the limit as h approaches 0 of f of x plus h multiplied by the limit as h approaches 0 of g of x plus h minus g of x over h. And then we add the limit as h approaches 0 of g of x multiplied by the limit as h approaches 0 of f of x plus h minus f of x over h. So now notice this thing here, this is just the definition of g prime of x. And this thing here, that is just the definition of f prime of x. So this is g prime of x, and this is f prime of x. And limit as h approaches 0 for g of x, that is just equal to g of x since it doesn't depend on h. And then the first one, we're given that f is differentiable. And recall that differentiability implies continuity. So this means f is continuous. And if f is continuous, we can go ahead and do a direct substitution. So which means if we substitute in h as 0, this is just f of x. So finally, we end up with this is equal to f of x times g prime of x plus g of x times f prime of x. And since it's addition, the order here doesn't matter. So therefore, we have proven that the derivative of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x, which is the product rule. And now let's do a quick recap of what we covered in this video. We saw how when you have a product inside a quotient, or vice versa, there's no need to panic. You can do a side quest by calculating the smaller derivatives separately and then substituting it back into the main formula. When working on problems where you're not given the equation but with a table of values, make sure to write out the formula using f of x and g of x first and substitute in your numbers last. Remember to trust the structure and not your mental math. And lastly, we went over the proof of the product rule. We employed the adding zero trick in the limit definition. Understanding why math works separates the students from the masters. And now it is your turn to give this a try. Can you find the derivative of f of x here? Make sure to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.